All right, group 8. A battleship fires 2 shells at the same time towards enemy ships. So we've got one that's going to try and hit ship A and one that's going to try and hit ship B. To hit ship A, it fires the shell at an angle of 65 degrees, and to hit ship B, it fires at 45 degrees. The initial velocity of both shells is 200 meters per second. So no matter whether it's trying to hit this one or this one, it has an initial or resultant velocity of 200 meters per second. So the first part says, what is the vertical component of the velocity for the shell fired at A and at B? So I'm going to have to do both of these. So first I'm going to set up my triangle. So here's the one that's going to hit A. So I know that the initial velocity is 200. I know that the angle for shell A is 65. And I'm interested in the vertical component. Okay. When we define our sides of our triangle based on the angle, this would become my opposite side, and this is my hypotenuse, right? So when I go to my trig functions, we see that sine will do this for us. So sine of 65 equals Vy over 200. When you work that out, you get Vy equals sine of 65 times 200, right? I got to multiply those two together, which is 181.26. Okay, I'm going to do the same thing for B. Let me draw myself a new triangle. Now this is 45, 200. I'm looking for Vy. Sides still are defined the same, right? Still opposite and hypotenuse, so I can use the same function, but I have to put in my new angle. So sine of 45 equals Vy over 200, meaning that for the one that's fired at B, the vertical component is sine 45 times 200. Which is 141.4. Okay. How much time will it take the shell fired at enemy ship A to reach the top of its trajectory and then B? So a couple things I want you to think about. We can use what we know about the top of the trajectory to sort of help us to answer this. If we just pretend that this is the only part of the path we're interested in, is up to here and up to here. At the very top of the path for each of these, we know that the velocity, we're going to call it the final velocity, but it's the velocity at the top, would be 0. Okay, so I can actually utilize that to help me solve solve the question. So we know for A, right? I'm still going to start with A, that the initial vertical velocity, or VIY, that's what these actually are, was 181.26. We're going to say, imagine that we could stop this thing right at the very top. The final velocity at the top would be 0. Okay, we know that we have acceleration due to gravity. Okay, and we want to find time. So when we come to our formula sheet, sorry about the lights behind me, guys. Come to our formula sheet. I'm going to use this one right here. So t equals the square root of 2 times the distance in the y direction divided by g. Oop, no, I'm not going to use that one. See, sometimes everybody makes mistakes. I want to know how much time, but I don't know anything about distance, so I can't use that equation. So I'm going to come back to the drawing board and look again. In this case, I know initial velocity, final velocity, acceleration, and I want to find one that will help me get to time. So I'm going to actually use this one right here. Final velocity equals initial velocity plus AT. Okay, so final velocity, 0, equals initial velocity, 181.26. Plus acceleration multiplied by time, because that's what we're going to look for. Okay, so I'm going to start to move stuff around. Now, I'm going to end up getting a negative number. I don't want you to worry about it. We're just going to say it's positive because time is always a positive. Okay, so I would subtract 181.26 from both sides. So negative 181.26 equals 10t. I'm going to divide both sides by 10. both sides by 10. So the time for A would be 18.13 seconds. Okay, so now I'm going to try the same thing for B. It should be a little easier for B because we've got some stuff kind of already thought out. So the VIY for B is 141.4. The final velocity, if we imagine that we stopped here at the top of the path, we said is 0. Okay, acceleration is still 10 meters per second squared, and I still want to know time. So I'm going to use exactly the same equation I used here. So 0 equals 141.4 plus 10t. Subtract 141.4 from both sides. So negative 141.4 equals 10t divided by 10 divided by 10. So time for that one is 14.14 seconds. Okay, so this is the time for A. This is the time for B. Okay, so it says which enemy ship will be struck first, or will they be struck at the same time, and why? Well, thinking about this time, right, this is the amount of time it takes to go to the top, which means it would take an equal amount of time to come to the bottom. So basically this times 2 or this times 2. So which one is going to hit its ship first? Well, this one is going to spend less time in the air than this one. So even though this one didn't actually go as far to the side, right, battleship A is closer, because it goes so high into the sky, it spends a lot of time going up and then coming back down. It would actually take longer to hit this one than it would to hit this one because it doesn't go as high, so the time in the air is less. So ship B would be hit first. Because the time in the air is shorter.